Assalamu alaikum. Hello, I hope that you are doing well. This is the first video about integral academic way. So here we will deal today with this type of integral, the integral of dx over a x squared plus bx plus c. A is different of 0 to have a is different of 0. Actually, we have three possible cases. First case, when delta is equal to 0. The second case, when delta is greater than 0. And the third case, when delta is less than 0. As an example, to understand, to let you understand better, I propose these three integrals. The first one, the first case when delta is equal to 0. So here we have the integral of dx over 2x squared plus 4x plus 2. This is equal to 1 over 2, the integral dx over x plus 2x x squared plus 2x plus 1, which is equal to integral 1 over 2 dx over x plus 1 power 2, and this is equal to 1 over 2 the integral of x plus 1 power minus 2 d of x plus 1, which is equal to 1/2 times 1 over minus 2 plus 1, this is alpha, times x plus 1 power minus 2 plus 1 plus a constant, which is equal to 1/2 times 1 over minus 1 times x plus 1 power minus 1 plus c, which is equal to 1 over 2 times minus 1 over x plus 1 plus constant, which is equal to minus 1 over 2 x plus 1 plus a constant. This is the first case when delta is equal to 0, and this is an example. Here delta is equal to 4 power 2 minus 4 2, which is equal to 0. The second case, here we have also the second case of this kind of problems. For the second case, let us take dx over 1 over 2 x squared plus 2x minus 1. This is equal to 1 over 2 the integral dx over, here we have x plus 1 square, we get x squared plus 2x plus 1, so minus 1 minus 1. The first minus 1 to have this expression, and the second minus 1 is this minus 1, which is equal to 1 over 2 dx over x plus 1 square minus 2. And let me do it like this: minus the square root of 2 minus 2. here we put a change of variable, The change of variable, we put x plus 1 over the square root of 2. This is equal to t. So this is the change of variable. To get what? To get 1 over, so we have 2, this one, and from here we take the square root of 2 power 2 as factor, so times 2, the integral dx over x plus 1 over the square root of 2 square minus 1. With this change of variable, we get dx equal the square root of 2 dt. And this and the integral takes the form, so 1 over 4, the integral, the square root of 2 dt over t square minus 1. And here we have, which is equal to 1 over 2 the square root of 2, the integral of dt over t square minus 2, which is equal 1 over 2 the square root of 2, let me write 4, the integral of dt over t plus 1 minus the integral dt over t minus 1. So here we have t minus 1. So here we have minus, and here we have plus. So we have t plus 1 minus t minus 1. So this means 2 times we have t minus 1 square, t square minus 1. And the 2 with what we get here will be cancelled with 2 to get this one. To finally arrive at 1 over 4 to the square root of 2 ln t minus 1 minus ln t plus 1 plus a constant, which gives us 1 over 4 the square root of 2 ln the absolute value of t minus 1 over t plus 1 plus a constant. This case can be produced when delta is strictly greater than 0. The last case, as an example, is when delta is strictly less than 0. dx over 1 over 2 x square plus 2x plus 2. Delta is less than 0. We have 2 square 4 minus 8 minus 4 minus 8, which means that it is less than 0. So once again, this is equal 1 over 2 the integral dx over, here we have x plus 1 square, so it gives us x squared plus 2x plus 1. So here we have this minus 1 plus 1, this one, plus 2, this one. which gives us 1 over 2, the square root dx over x plus 1 square plus 1. Then, I am just joking, we take 1 as a factor to divide by 1. So in the case 1, the square root of 1. In the case 1, here for example, we have 3. For example, here we have, suppose that we have 3. Then we take here the square root of 3 and the square root of 3 square, or just the 3, to keep here 1, and here what we have times 3 in this case. But in our example, we have just 1, so we will just let it as it is. With a change of variable here, we get 1 over 2, the integral of dx plus 1 over x plus 1 square plus 1, and this is the tangent function. So finally we get 1 over 2 arc tangent x plus 1 plus a constant. Actually, in general case, we take x plus 1 equal t, so dx equal dt, and we get dt over t squared plus 1, which gives us arc tangent t. Then we replace t by x plus 1. So we can summarize this as a flow. The type of integral primitives dx over a x squared plus b x plus c, a is different of 0, even we will be in this case elementary 1 dx or on over bx plus c. So when we have this, we have 3 possible cases. First case, delta equals 0, so we make just a little change to have the integral. Delta greater than 0, we have two distinct solutions, and then we have ln. And the third case, we have delta strictly less than 0, and in this case we have arc tangent. So here we have elementary integral from the type integral of x power alpha dx. After making the change of variable, the second case we have ln t minus over t plus. I forget to replace in the first case t. The second case I forget to replace t by its value. And in the last case we have arc tangent t, then we replace t by its variable. In the second case, in this case, I find 1 over, I think that 4 the square root of 2, if I remember, ln t minus 1 over t plus 1 plus constant, but t was x plus 1 over the square root of t, so we have to replace here this to get what? To get 1 over 4 the square root of 2 ln t is x plus 1 over 2, so we have here, we have x plus 1 minus the square root of 2, x plus 1 plus the square root of 2 plus a constant. Thank you for watching. See you inshallah soon.